Welcome back to the class of simultaneous linear equations in two variables of class 9 ICC board. Now in this class we are going to use elimination method to find the variables. In the previous class we have already used substitution method. So let us first start with the elimination method steps. Now these are the two steps for elimination method to find the values of the variables x and y in a two variable equation. Okay, so you have to multiply one or both equations by suitable numbers. The point is you are going to make the coefficients equal by taking their LCM. Now when you solve examples we are going to see that will be easier, so that the addition or subtraction eliminates one variable. So first what you are going to do is you are going to eliminate one of the variables, then you are just going to find the single variable equation which you can solve for that single variable, and then put it and find the other variable also. Okay, so these are the two main steps. Let's move on to the questions. This is the first question of exercise 5.2 ML Agarwal. Now I have already written the two equations as exactly given in the question. So this is our equation number 1 and this is our equation number 2. According to the first step, we're going to disappear or eliminate one of the variables. Say we don't need this x variables. Okay, so we want to make it disappear. So when boom, x is gone. Okay, so now we can move on to the next step. That's we have one variable now for y minus 2y. If we add it for y minus 2y, it's 2y and 12. So y equals to 12 by 2, 6. Can we do that? We have already found y. So can we do it? No. That's not the right way or right process. So that's not the process. We have to ask x to come back. Hey x, you cannot go or disappear like that. So you have to come back. Please come back. Okay, now we have our x back. So what is the process? Let us consider a different scenario. With our second equation, we can have a different one. Suppose we have 3x plus 4y equals to 10, and the second equation, suppose instead of 2x minus 2y we had 3x minus 2y equals to 2. Now in that case, since the coefficients are equal, so we can make this x term disappear. Like if I subtract, since the signs are same, we have to subtract. So 3x minus 3x, it's gone. And when we are subtracting, we have to change the sign of each of these, because when you are subtracting the whole equation, right? So once you are opening the bracket, minus into minus plus, so the sign changes. So in that, if our second equation was minus 3x minus 2y equals to 2, now since the signs are different, now we don't have to subtract. If we just add it, so adding does not changes the sign. So 3x, if we open the bracket we get minus 3x, we are adding it, so this is gone. 4y minus 2y is 2y and equals to 10 plus 2, 12. So y equals to 6. So these are the two cases when we already had the coefficient equal to the coefficient of x variable in the first equation, but we don't have it. So now the process is to write those given equations with their x variable coefficient equal. That means I have to multiply the first equation with 2. So our whole equation becomes, if I multiply the whole thing by 2, I get 6x plus then 8y equals to 20. And the second equation, we have to multiply it by 3. Since we are taking the LCM of 3 and 2, we have to multiply the first one with 2 and the second one with 3. So now it becomes 2 into 3 6x and minus 6y equals to 6. The next process is we have to compare those coefficients. Since both are of the same sign, 6x and 6x, we have to subtract to make x variable disappear. Now when you are subtracting, if you open the bracket, you know that this becomes minus 6x, this becomes plus 6y, this is minus 6, and so x is gone now. 8y plus 6y 14y, 20 minus 6 is 14. So y equals to 14 by 14, so y is 1. Now once you find y, it's very easy to find x, because you just have to put the value of y in one of the equations, any equation you want. Suppose we put the value of y in the second equation, so I think that's easier to use the second equation. So just write from which equation, or from, you have to write the whole equation, or you can just write, since I have already named these equations as 1 and 2, so I can write from 2x minus 2 into y, the value is 1, so that's 2. So I have 2x minus 2 equals to 2, so 2x equals to 2 plus 2 4, and x equals to 4 by 2, that's 2. So we have our x value and we have our y value, so that's our answer. X equals to 2 and y equals to 1. Okay. In this question, you can see those two equations and the coefficients are in the form of fractions. Okay. It doesn't matter, because you can just simply take LCM and convert it to normal equation, or you can continue with the same type. We just have to equate the variables coefficients, like here we have made the x coefficient equal, you see in both the equations I made it 3 by 8, so that's our LCM. How do we get 3 by 8? You can just see that if I multiply the first equation with 1 by 2 half, so what do I get? 3 by 4 into 1 by 2, that's 3 by 8. So I already have 3 by 8 in the second equation. This is our second equation, this is our first equation. So in the second equation we have already this 3 by 8, so no need to multiply the second equation. We are just writing the second equation as it is, and the first equation we are multiplying this whole thing by half. So we get 2 by 3 into half is 1 by 3y, and 1 into half is half. So when you solve it, since the signs are same, we have to subtract and change the signs, like this minus 1 by 6y becomes plus 1 by 6y, then we have here minus 1. Okay, so x term gets vanished and we have minus 1 by 3y plus 1 by 6y equals to half minus 1. So half minus 1 is minus half, right? So that's minus half. And here we have minus 1 by 3 plus 1 by 6, y taken common, so 1 by 6 minus 1 by 3, we get minus 1 by 6. So minus on both sides, minus 6 goes to the numerator and 1 goes to the denominator. So we have 2 goes 3 times, so y equals to 3. And just putting the value of y in the first equation, we have in place of y 3, so 3 gets cancelled and x comes to 4. So x is 4 and y is 3. Now all the questions you have to follow the same process. No matter whatever the type of equation, you are just converting the given equations. Like here you have the variables x and y like in this form, so you are going to first convert them into the general form of the linear equation in two variables. So whatever the process is, taking the LCM and writing it in the normal form. Okay, 13x minus y equals to 12. So once we get one of the equations, we name it our first equation, and in the same way or same manner, when we process the second equation, we get x minus y equals to 3, and this is our second equation. So we already have the coefficients of y as -1, so the coefficients are same, so we don't have to multiply the equations with any other number. So in that case, we can just, since the signs are same, we have to subtract. So again the signs change, so here we have minus x plus y, minus y plus y gets cancelled, so it's gone. 13x minus x, 12x, 12 minus 3, 9, so x equals to 3 by 4, 9 by 12 is 3 by 4. And putting the value of x in one of the equations, in the second equation we have chosen, you can also choose equation number 1. So in place of x I have written 3 by 4, and minus y goes to that side, we have y equals to 3 by 4 minus 3, so y equals to minus 9 by 4. Okay, now see this equation here. In place of constants we are using a and b, but our variable is same like x and y. So in the first equation we have 1 by a, in the second equation we have a. So the coefficients are different whether we take a part or the b part. So our equation we have to rewrite with some equal coefficients, right? So I've chosen x variable to be eliminated. So what I did is I multiplied the first equation with a, so that 1 by a into a is cancelled, so we have x. So here we have, I multiplied the whole thing by a, so 1 by by into a, so that's a by by, and whatever you multiply with 0 you get 0. Okay, in the second equation we have to multiply this with 1 by a, so that a gets cancelled, so we have x, and we are multiplying by 1 by a, so b by a y, and here we have a square plus b square by a. Now since we have again the coefficients with the same sign, we have to subtract. That comes to minus a by by minus b by ay equals to 0 minus a square plus b square by a. Okay, so when we calculate or find the value of since we have already eliminated x, we have to find the value of y here, taking minus y common and processing the other constants. What you get is a square plus b square by ab, taking LCM ab, and here we have this. So y equals to ab goes to the numerator, a square plus b square goes to the denominator. You can cancel a square plus b square and you can cancel a, so y is equal. The value of y equals to b in equation 1, so from 1 we have x by a minus y by b, so b gets cancelled here. In place of y I've written b. Okay, so now x comes to a, so we have x equals to a and y equals to b. If you see this equation, that's ax plus by equals to 7 when x equals to 2 and y equals to 1, and ax plus by equals to 1 when x equals to -1 and y equals to 1. So we have just used those values of x and y in the given equation to find our required equation. So the first equation is when you put x equals to 2 and y equals to 1 in place of x and y in the equation, we have 2a plus b equals to 7. This is our first. When you put x equals to -1 and y equals to 1 in that equation, we get minus a plus b equals to 1. Okay, this is our second equation. Now when we have two equations with the variables now a and b, it's very simple to solve these two equations. You can see that's b, the coefficient is same, and to subtract the second equation from the first equation, b gets vanished, the sign changes, 2a plus a equals to 3a, and this one is 7 minus 1 6. So a, you should get you need to solve it, and you should get a equals to 6 by 3. You should get a equals to 2, and when you put a equals to 2 in one of the equations, say I'm putting in this, so b equals to, you get 2 minus 2 goes to that side, you have 3. Okay, now this is a different type of question where you have 3 equations instead of 2, and they're asking you to find whether the following equations hold simultaneously. Now what do you mean by hold simultaneously? It means for a particular variable, for a particular value of x and y, these all 3 equations are true. Now how do we find the value of x and y? You also have to find the value of x and y. So let us not use all the 3 equations at a time. We will go by our usual method, solving any 2 equations first. So you can choose 1 or 3, you can choose 2 or 3. We have just started here with equation number 1 and 2. The coefficient of x is 3 and 11. So how to make it equal? By multiplying the first equation with 11 and the second equation with 3. So the LCM is 33, and if you process it, you get y equals to 2. Then putting the value of y equals to 2 in the second or first equation, we get x equals to 7. So now what we need to do is whether the value of x equals to 7 and y equals to 2 holds true for the third equation. So we have to verify that. Now in case of verification, we need to find out the value of the left hand side first and then see whether it is equal to the right hand side. So putting the value of x and y in the third equation, this is our third equation, 5x plus 4y, on the left hand side of the first equation, third equation. Okay, so in place of x we put 7 and y we put 2, and solve it, we get 43, which is equal to the right hand side. So that means those values of x and y which holds true for these two equations, number 1 and equation number 2, also holds true, because it is true, left hand side is equal to right hand side, also holds true for the third equation. That means x equals to 7 and y equals to 2 satisfies all the 3 equations, and hence those 3 equations, therefore they hold simultaneously. That's all in this class. In the next class, we are going to learn about cross multiplication method of solving linear equations in 2 variables. Thank you.